Okay, today we're going to progress into problems that look like this one. -5 times the square root of 126. Alright, this means -5 times the square root of 126. So you're still going to be simplifying radicals, but you're going to break this thing apart first. Just add your times sign. Yeah, 126. And then you take -5 times, and you factor this 126. So you find the largest perfect square that goes into 126. So take your 126 and start dividing it by perfect squares. Take your 126 and start dividing it by perfect squares. Alright, so 9 is the largest perfect square that goes into 126 evenly. Say again? 64 doesn't go into 126. It goes into 128. So look, you take your -5 now, times the square root of 9 is equal to 3, times, and you got your square root of 14. So what you're doing is you're breaking apart this problem. You're pulling all of the perfect square factors out of whatever's under the radical. Once you pull this problem apart and you simplify everything, you can put the problem back together. So in this case, your next step now would be to multiply the -5 times the 3. You're allowed to multiply anything not under the radical by anything else not under the radical. So -5 times 3 is -15. And the square root of 14 is in simplest form. So -15 times the square root of 14 would be your simplest form.
How do you put that in your calculator?
You don't. There's nothing to put in your calculator. Alright, just a negative sign outside the radical. Negative sign times the square root of 112. When you see that, just make it a -1 times the square root of 112. And by doing that, you won't forget about it. And then factor just like you did yesterday. This would be -1 times. Take your 112 and start dividing it by perfect squares. Anybody? 16 and 7. Good. So square root of 16 times the square root of 7. So now simplify your square root of 16. So you get -1 times 4 times square root of 7. And your -1 times your 4 is -4 square root of 7. Alright, so if there's a number outside the radical, you're just doing the same thing that you did yesterday, except when you simplify, you have to take that number that's outside the radical and multiply it by whatever else is outside the radical. Make sense? Okay. Alright, so now we got to talk about variables for a second, because we're going to start adding variables to these today. So, write this down. These are variable perfect squares. Alright, we're going to start with the square root of x. The square root of x is in simplest form, and it's equal to the square root of x. The square root of x squared is a perfect square, and it's equal to x. The square root of x to the third. The square root of x to the third is equal to the square root of x squared times the square root of x. X squared is the largest perfect square in x to the third. So this simplifies to x times square root of x. You guys remember when you multiply, when you have same bases and you're multiplying, you add the exponents? Do you guys remember that? Alright, well if you don't remember it, that's what happens. Alright, the square root of x to the third is equal to the square root of x squared times the square root of x to the first, because 1 plus 2 equals 3. Alright, that's how that got simplified. The square root of x to the fourth. That's a perfect square, and it's equal to x squared. All of your even exponents are perfect squares, and their square root is half the exponent. So if you take the square root of x to the fifth, that's equal to the square root of x to the fourth times the square root of x, which equals x squared times square root of x. The square root of x to the sixth is a perfect square. And what's the square root of x to the sixth equal to?
X to the third.
X to the third. And is anybody starting to see a pattern? Square root of x to the seventh. Square root of x to the sixth times square root of x. X to the third, square root of x. And the square root of x to the eighth. It's even, so it's a perfect square, and it's equal to x to the fourth. Y'all see the pattern for the odd numbered powers? So if we go dot, 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 and we go down to the square root of x to the 21st. Square root of x to the 20th times the square root of x. X to the 10th times square root of x. Good. Do you see the pattern?
Yes.
This 21, right? If you subtract 1 from it and divide it by 2, you get a 10, don't you? Times the square root of x. If you take this 7, subtract 1 from it, you get 6. Divide it by 2, you get 3 times the square root of x. That's your pattern. So now you're going to be solving problems or simplifying radicals that have variables in them, like the square root of 54 n to the 7th. When you're simplifying these radicals with variables, your first step is to break apart the radical. Here's what I mean. Take your square root of 54 times your square root of n to the 7th. If you do that first, you're making the problem much more simple. Because the square root of 54, you worked on that yesterday. The square root of 54 simplifies to the square root of 9 times the square root of 6. And then you just have to worry about the end of the 7th, and you just did that. That's the square root of n to the 6th times the square root of n. And then you simplify your perfect squares. Square root of 9 is 3 times your square root of 6 times the square root of n to the 6th is equal to n to the 3rd, and your square root of n is in simplest form. You have everything in simplest form right now. So what you have to do is multiply the numbers that are not under the radical. So you got 3n to the 3rd. And then you have to multiply the numbers that are under the radical. 6 times n is 6n. There's your simplest form. So the only thing different was this. Agreed? And that comes off of this list. Here's your square root of x to the 7th. It's equal to x to the 3rd times square root of x. Your n to the 7th is equal to your n to the 3rd times square root of n. You just have to put it back together in the last step. Try this. Negative m times the square root of 80m to the 9th. Again, your first step is to break it apart. Take negative m times square root of 80 times the square root of m to the 9th. Now factor your number and factor your variable. So negative m times, what does the square root of 80 factor to? Neither of those are perfect squares. Largest perfect square that goes into 80. 16, and how many times does it go? Square root of 16 times square root of 5. Largest perfect square that's in m to the 9th. M to the 8th times square root of m. And now you simplify your perfect squares. So negative m times 4 times the square root of 5 times m to the 4th times the square root of m. M. What's next?
Do add them together. They'll like these.
Combine what's outside the radical with what's outside the radical, right? So a negative m times a 4 times an m to the 4th. What's m times m to the 4th?
M to the 5th.
M to the 5th. Wouldn't this be negative 4m to the 5th? And what goes under the radical? 5m, good. So there's your simplest form. Isn't this fun? I love simplifying radicals. Too much work. Someone says it's too much work. How about 3 times the square root of 24 t to the 3rd? Alright, take it apart again. So you got 3 times the square root of 24 times the square root of t to the 3rd. Factor your radicals. 3 times. What's the largest perfect square in 24? 6 is not a perfect square. 4. Square root of 4 times square root of 6. Largest perfect square in t to the third. T squared times square root of t. Simplify your perfect squares. 3 times 2 times square root of 6 times square root of t squared, t times square root of t. So outside of the radical, you got a 3 times a 2 times a t, which is a 6t. And inside the radical, you get a 6 times a t, which is a 6t.
Wow, that's cool.
And that is your simplest form, ladies and gentlemen. Having fun yet? I love this. Having so much fun. Let's do another one. Let's do negative square root of 194. Check that. 192 t to the sixth. So you break it apart. You make it negative 1 times square root of 192 times square root of t to the sixth. Square root of t to the sixth. Which is negative 1 times 192. Largest perfect square that goes into 192. Say it again. 64. Good. Radical 64 times radical 3. And what do you know about the square root of t to the sixth? It's a perfect square, isn't it? So it's equal to t to the third. And what do you know about the square root of 64? What does that equal? So you can cross it out and make it an 8. So what's negative 1 times 8 times t to the third? Negative 8t to the third. And what's left under the radical? Square root of 3. Good. And you are finished. Simplest form. No perfect square factors underneath the radical. Okay? Anybody have a question or need to see another problem?